Hey everyone, I'm sure you noticed last week we released our DynamoDB only version of Webiny, finally. We were eagerly awaiting that one, and we got lots of questions about, can I later upgrade to Elasticsearch, or can I downgrade or just switch my current system, which is on DynamoDB plus Elasticsearch? Can I switch it to just be DynamoDB only? So we thought, let's use this session and kind of describe the whole thing about how storage layer works with Webiny, and it will answer all your questions regarding switching, storage, drivers, and things like that. So first, we need to take a step back and look at how traditionally systems handled storage layers. And probably just by looking at this diagram, you already know what I'm going to talk about. As soon as you see ORM, you will know that it has something to do with like relational mapping of your objects, your classes, your data to some kind of an abstraction and sitting on top of a database management system. So that's what we started with in Webiny version 4. I'm sure if you use Webiny version 4, you most likely remember the Komodo thing we had. It was an ODM, like an object document mapper. We wrote at Webiny to make use of MongoDB, and later we attempted to make it work with Dynamo, but it failed miserably because all kinds of abstractions are difficult to pull off, because every good tool like DynamoDB or Mongo, or be it Cosmos DB or any database, they are good for their specific strengths. Any database can do basic CRUD operations. Any database can do a write, an insert, an update, and a delete. But as soon as you start going further and doing more complex stuff, that's where you want to really utilize those strengths or specialized storage features. For Dynamo, it may be GSIs and a completely different way of storing data. For MongoDB, you may be using like its aggregate functions, which are really crazy good, but there is no such thing in Dynamo, right? And not in SQL. So if you slap an abstraction layer on top of all those databases, you end up with having a create, read, update, delete set of operations, and you're done. Like, that's what you get. And we were trying to make it work, but at the end we said, enough is enough. It doesn't work. We cannot optimize, and we cannot make the best use of the tools we have available today if we keep trying to abstracting things away. So traditionally, applications would have their business logic, and then they would use an ORM to store data, to read it, and to delete it. And they would use some kind of query builders to write those basic operations. But then you reach the point where you say, okay, this is executing quite poorly, and I need to make it faster. And then what happened is your business logic would contain custom SQL queries. Because usually ORMs are use some kind of a relational database underneath. So you would end up having your business logic mixed with custom SQL queries just to make it perform better. And it's unmaintainable. It defeats the purpose of even having an ORM. Why not go with plain SQL from the very beginning? So that is the traditional approach. When we started building this Webiny version 5, the one you're using today, we said, let's try a different approach. So we created this concept of a storage operations. Swapnil, if you can switch to the next slide, it will depict what we have today. So the Webiny approach of using storage in general is every application has a so-called storage operations like a driver. We can call it a driver, and it's replaceable, and it's focused strictly on that application. So a file manager has a special set of methods or an interface you need to implement, and that layer can work with any database you want, because business logic still sits in the application itself, but it is calling methods on this storage operations layer. That storage operations layer can then work with native storage like services, right? It can be DynamoDB, but we are not using an abstraction on top of that. We are literally using DynamoDB clients. So we can use all of the strengths of DynamoDB. For example, for page builder, you may say, MongoDB is a better option for me. I will need some kind of crazy statistics or whatever. And I may want to use MongoDB aggregation features. So you can say, okay, my file manager still works with DynamoDB, but my page builder will work with MongoDB. So in a sense, every application we have in Webiny, it's a standalone app. You will never be writing queries and doing crazy left joins or cross joins between file manager and page builder. So think of these apps as kind of a microservice of sorts. Even though they all live in the same Lambda function, they never intersect on the storage layer. And I just have MongoDB here as an example. We don't support MongoDB purely because it is not a serverless service yet. They do have plans and they're working on making it serverless. And when they do, we probably will revert back to it and maybe even consider implementing a storage for it, but it's not on the roadmap right now. So moving on, imagine a scenario where you need something really crazy like headless CMS, where you want to use DynamoDB because it's serverless, but then you need to have unpredictable access patterns because you can build dynamic content models. DynamoDB is all about knowing your access patterns. With headless CMS, you don't know your access patterns because you don't know the data users will be modeling. So you say, okay, I will use DynamoDB to store, just store data, but for searching and filtering and all those kind of crazy full text search operations, I want to use Elasticsearch. So in traditional architecture, you would have your ORM storing data, but then in your business logic, you would have Elasticsearch slapped on top of it. And again, you end up with a mess. So with the way we structure our storage operations now, you can use 1 or 2 or 3 remote services to store your data, and you encapsulate it in storage operations. So at some point, you may say, okay, this page builder here, like it's okay, it works fine, but I would like to experiment with a different storage. And you can just replace our existing package. It's a simple NPM package. You can just use a separate package which works with a different storage. It can be Cosmos DB or whatever you want. It can be a flat file stored in S3. So you can experiment by replacing bits and pieces, or even just grabbing the original implementation and wrapping it around your custom stuff and then setting it in. So it's really flexible. And it allows you to use all the specialized storage features. You no longer have to limit yourself on basic CRUD operations. You can pick what storage you want to use for a specific use case. So page builder may be a simple use case, but headless CMS can be more complex. So you may use a more specialized services to power that application. So this brings us a couple of benefits of easy experimenting with different implementations and just having different storage, even if we officially do not have a package for, let's say, MySQL, right? We don't. You may say, okay, I want to have MySQL and I want to use it for page builder. And then you just grab a TypeScript interface and you implement your storage layer yourself and then just replace it in your GraphQL function setup, and it will just work because we just ask from your implementation to respect our interface, and that's all we care about. The cons of this approach is that there is more to maintain. You do have, I wouldn't say it's a copy, but it is an extra package, and you do have to write more code, more setup code, and stuff like that. And it's a lot more difficult to set up for testing. Like setting up Jest for page builder with 5 or 6 storage operation drivers it's challenging. So on that front, it's a bit more difficult, but if you consider all the pros you get with it, I would say it's worth it. So that's kind of what we have today. And if we compare our 2 storage layers we provide today, they are not replaceable in place, in a sense that you cannot start a project using 1 storage layer and then in a month you decide, oh, I want to switch to Elasticsearch. You cannot do that. The reason is each one of these implementations are they store data differently. They store data with all the limitations of each service in mind. So for DynamoDB, for example, you cannot filter by any field you want. You cannot sort by anything you like. You have to think in terms of which fields am I going to use for sorting, and then optimize your sort keys and stuff like that. So if you use that driver, it will store data in a certain way. If you just say, okay, my next project will be a bit more demanding and I will need Elasticsearch, then you just pick a different driver and you go with it from scratch, because that project will then store data entirely differently, because that implementation knows that it will have the luxury of Elasticsearch, and then we don't have to over-optimize stuff in Dynamo because we won't even be querying Dynamo. So those are the things that make these things not easily swappable. It's not hot swappable mid-project. You have to decide upfront. If you want to make migrations, it's possible. You would have to use so you cannot write database migrations. You would have to write scripts which use the API, use your API key, and then you fetch data from one system and use another endpoint and another API, and you insert that data back using GraphQL API, but then the storage layer will take care of storing it in the way that's appropriate for that storage layer. But you cannot just copy a DynamoDB table across and say, I'm done with my migration. It doesn't work that way. So that is to answer all the questions about downgrading to DynamoDB only or upgrading later on. At some point, it will probably be possible with like out-of-the-box scripts that we may provide, but right now the only way is use your API. Just query for data and insert it into the other system, and that's how you go about it. So yeah, I think I will stop here.